So we measure memory system performance by its hit and miss rate, as well as its memory access time, or average memory access time. So a hit is defined as occurring when data is found in a given level of the memory hierarchy. A miss is when it's not found and when you have to go to the next level of the memory hierarchy. The hit rate is the number of hits over the total number of accesses, and the miss rate is the number of misses over the number of memory accesses. So if we add the hit rate and the miss rate together, we get 1. In other words, the hit rate is 1 minus the miss rate, and the miss rate is 1 minus the hit rate. Average memory access time is the time for the processor to access data. So if, for example, we have a system that just has a cache and a main memory, listed as MM here, the average memory access time would be the cache, time to access the cache, typically 1 processor clock cycle, plus the miss rate times the time to access main memory. If there are additional levels in the hierarchy, then that would be plus the miss rate of that level times that time to access that next level. So let's suppose in this example, our program has 2,000 loads and stores, so 2,000 memory accesses, and 1,250 of these these data values are found in the cache. The rest are supplied by other levels of the memory hierarchy. So what's the cache and hit and miss rate? Well, the hit rate is 1,250 number of hits over the number of accesses, 2,000. And the miss rate is 1 minus that, or in other words, 750 over 2,000. Written nicely here, our hit rate is 0.625, 1,250 over 2,000. Miss rate is 750 over 2,000, or 0.375. And you can note that these add together to be 1. Now suppose our processor has 2 levels of hierarchy, cache and main memory, and the cache access time is 1 processor cycle, and main memory access time is 100 processor clock cycles. What is the average memory access time of the program from example 1 from that previous slide? Well, average memory access time is the time to access the first level in the hierarchy. You need to access it to see if it missed or hit. So we have 1 cycle, time of the cache, plus its miss rate, which was 0.375, times the time to access that next level in the hierarchy, or 100 cycles. And so that's our average memory access time, the average time it takes to access any given data. Written nicely here, we have 38.5 cycles as our average memory access time.